Welcome to Principal AI. In this session, we'll dive into an important and widely used technique in the world of AI, Supervised Fine-Tuning, or SFT. This method is the bridge that transforms a general-purpose model into a task-specific expert. Whether it's a chatbot for a bank, a legal assistant, or a medical diagnostic agent, fine-tuning plays a central role in giving models specialized intelligence. So, what exactly is supervised fine-tuning? It's the process of training a pre-existing model, like GPT, BERT, or a vision model, using labeled data. That means data where both the input and the desired output are known. This method helps the model learn specific behavior or responses aligned with your task, such as classifying emails, answering legal queries, or extracting structured information. It's called supervised because it relies on examples where we explicitly supervise the model's output during training. To understand where SFT fits in, let's look at the overall AI model pipeline. First, there's pre-training. The model learns from massive generic datasets like all of Wikipedia or the open internet. It becomes a generalist. Then comes fine-tuning, where we take this broad knowledge and refocus the model on a particular task using high-quality labeled data. SFT bridges the gap between general-purpose capabilities and domain-specific intelligence, making the model more reliable in real-world tasks. Supervised fine-tuning involves four main ingredients. First, you need a labeled dataset. This is your goldmine of input-output pairs. Next, you choose a pre-trained model that you want to adapt. Then, a loss function is defined. It calculates how far the model's output is from the desired answer. Finally, using backpropagation, the model's internal parameters are adjusted to reduce the error. This process happens over many iterations until the model consistently learns the right behavior. There are several compelling reasons to use supervised fine-tuning. It allows a model to perform much better on niche or domain-specific tasks where general models tend to fail. You get more accurate and consistent outputs, fewer hallucinations, and improved alignment with your goals. It's also an efficient way to reuse massive foundation models without training from scratch, saving time and resources. In short, SFT customizes intelligence for your specific needs. Supervised fine-tuning is everywhere. In customer service, chatbots are fine-tuned using company FAQs and interaction logs. In healthcare, models are trained to interpret clinical notes or medical images. Legal assistants are fine-tuned on regional laws and precedents to ensure compliance. Even in finance, models analyze sentiment from stock news or social media posts. Wherever you have a well-defined task and quality data, SFT can add significant value. Large language models like GPT, LLMs, and Falcon benefit enormously from supervised fine-tuning. Once pre-trained, these models can be fine-tuned for instruction following, tone adaptation, or even industry compliance. A common example is training them to follow step-by-step instructions, what we call instruction tuning. This also plays a major role in alignment, especially when combined with RLHF, reinforcement learning with human feedback, to further improve usefulness and safety. Let's walk through a real-world example. Imagine a healthcare organization building a medical chatbot. They start with a pre-trained LLM. Then, using transcripts of doctor-patient conversations, they fine-tune the model. Now the chatbot can provide medically accurate responses, mimic professional tone, and even flag uncertainty in high-risk cases. The result? A safer, more helpful tool, tailored specifically to the healthcare domain. Despite its power, fine-tuning isn't without challenges. First, you need large, clean labeled datasets, which can be hard to find or expensive to create. Second, there's a risk of overfitting, where the model becomes too narrow and fails on new inputs. Bias in the training data can also be amplified. Lastly, fine-tuning requires compute resources and expertise, especially with large models. That said, newer techniques like parameter-efficient fine-tuning are making this more accessible. To wrap up, supervised fine-tuning is a cornerstone of how AI models are adapted to real-world use. It transforms generic models into experts, helps them understand instructions, and align with user needs. At Principal AI, we believe mastering fine-tuning is essential for anyone building intelligent systems today. If you found this valuable, don't forget to like, comment, and subscribe for more deep dives into practical AI.